Hello everyone, I'm Jay Joshi and welcome to the 20th episode of Learning Java. Today, we'll be learning about bubble and selection sort. So, what do I mean by bubble and selection sort? So, this sort basically means sorting of the elements in a one-dimensional array. So, let's say you have an integer array with some values, let's say 5, 3, 7, 2. So, these are the four elements 5, 3, 7, 2, and they're not in ascending or descending order, they're not in some particular order. So if we want to solve all these elements of this particular one-dimensional array in either ascending or descending order, we can use sorting techniques. So there are various sorting techniques like bubble sort, selection sort, insertion sort, etc. But I'll be only covering bubble and selection sort in this video. So first we'll be looking at selection sort. So selection sort is basically a sorting method which is a combination of searching and sorting. So what this basically means is, let's say you have an array 7432. So not 7432, 7342 example, which is not sorted. So first in selection sort, we'll search for the smallest element. So we can run a for loop, a simple for loop to search for the smallest element. So if we run a for loop, which is a condition of less than the total length of the array, and if we check an if statement, so if we assume the first element to be the smallest, and then we compare the first element to each of the elements, and if we find a smaller element, we can assume that to be the smallest element. So at the end of a particular iteration, we'll find the smallest element. So once we find that smallest element, we can put that in the the zeroth index, which is the first position of that element. So we'll put it in the zeroth index, and then we'll start for the first element. So we did the zeroth element, now we'll do the first index element. So we'll assume the first index element to be the smallest, and then we'll compare to the rest of the three elements. And so the first element gets sorted, then the second, then the third, and the fourth. So this is what selection sort basically is. So as it says in the PPT, it searches for the smallest element in case of ascending order or the largest element in case of descending order. So if it searches for the smallest element after the first iteration, it's going to put that after the complete iteration of searching for the smallest element in ascending order, it's going to put that in the zeroth index. In the second iteration, it's going to put the second smallest element in the second iteration, then third, then fourth, then fifth, and so on. So this process is repeated till all the elements are sorted in the array. And so it uses the word pass over here. The process is repeated till all the elements are in the correct position. And during each pass, which basically means each particular iteration, when the array elements are being compared. So at each point, the array elements are being compared, and you're searching for the smallest element or the largest and putting it in the 0th, first, second, third, fourth index, and so on. So let's have a look at the code of this particular program. So this is selection sort, and let's see how we'll implement this in Java. So I have a sample array int a is equal to 2743982. It's an integer array, and I have two temporary variables min and t. So this temporary variable is for swapping the values, as you can see over here. So if I want to swap the values between two particular variables, let's say a and b, I can't do a is equal to b and then b is equal to a. That won't work, because if I do a is equal to b, then the value of a will become b. And when I do b is equal to a, the value of a is already b. So b is equal to b. That doesn't make any sense. So you need a temporary variable. So you can do something like a is equal to t. Sorry, t is equal to a. So the value of a will be in t, and then you can do a is equal to b, so the value of b comes in a, and then b is equal to t, so t is a because you did t is equal to a. So this is how you can use a temporary variable to swap two variables. With three variables it's just another story, but this is for two variables which you'll require in both selection and bubble sort. So this is what it looks like. I'll be explaining it in a moment. And I have the minimum variable. So in this particular example, I have this integer array, and I'll be sorting it using selection sort in ascending order, which is from smallest to biggest element. So I have the minimum variable, which will find out the smallest element in each particular iteration. So mostly in all the sorts, there are usually there's two or more for loops or other types of loops, but we mostly use for loops. So in both selection and bubble sort, there are two for loops, nested for loops, which means one for loop inside the other. So let's have a look. First, we have for the first for loop, int I is equal to 0, I should be less than a dot length minus 1. I'll be explaining this minus 1 in a moment. I plus plus. So this is the basic thing. So 0th index and the index should be less than the length of the array. Minus 1, I'll be explaining as we move on. So as soon as it enters the biggest for loop, it puts the value of I, which is the particular index value, into min. So in the first iteration, for example, it'll assume the 0th thing, this number in the 0th index to be the smallest. So for right now, it assumes that the minimum value is in the 0th index. So the value of min is currently 0. Then we have another for loop in j is equal to I plus 1. So j is currently 1 and j should again be less than length because index should be less than length and j plus plus. So first we have the index of the first element and then we have the index of the second element. So the 0th index and the first index. So then it compares inside the j loop. So inside this loop is the main particular iteration for each particular pass. And inside the for j loop, we have the internal comparison to check which is the smallest or the largest element. So smallest in this case. So we compare two variables, which is the smallest variable, which we assume to be the first variable, and the j variable, which is 1 greater than I right now. And it'll be 2 greater than 3 greater than as the thing moves on. So if the j variable, the jth index variable is smaller than the what we thought was minimum, then the minimum value becomes j. So let me explain this again. Right now we have assumed that the smallest element is in the 0th index over here. Min is equal to I, it's in the 0th index. But if we find out that the value in the first index over here, because it's I plus 1, 0 plus 1, in the first index is even smaller than the value at the 0th index. So we know that as compared to 0 and 1, 1, the element in the first index is smaller. So the new value of min becomes j. So the new value of 1 min will become 1, for example, and then it's going to compare again. So it's going to check if this one is smaller than the third element, second element, then third element, then fourth element, and so on, whatever thing is there. So it's going to keep on comparing each minimum value which it finds out. But let's say, like in this case, the second value is 7. So I is 0 right now. The value of I is 0. So the value of this a of min is 2, and a of j, which is a of 1, will be 7. But 7 is not less than 2, so it will not go in this if loop. It will go again. Then it's going to go to j of 2. Then it's going to compare the third element basically with the 0th element. So it's going to compare 4 and 2. 4 is still 2 is still smaller. Then it's going to again iterate. It's going to check the 0 1 2 third element, just 3. 3 is still bigger than 2, then 9, then 8, and then 2. When it compares 2, again they both are equal, so nothing will happen. So then the j loop ends and the smallest value, what we assumed, was correct. And if it was wrong, then the new value of min will become whatever the smallest value of the particular index was. Let's say the value over here was 1. So when it would have come to this comparison, j value would have been 0, 1, 2, 3. So the value of j would have been 3. So it's going to check if a of 3 is less than a of 0, which is true because 1 is less than 2. Then the value of this min will become 3. So so we know that the smallest element is in the third index. And it's going to continue to check if there's a number even smaller than 1, but we won't find any. So the value of min at the end of this j loop will be 3, which is the smallest value, smallest value of the index of that particular element. Then if the value of min is not equal to I, because if it's equal to I, then we already know that it's already sorted and the element of that particular I index is already sorted. So the value we assumed is correct. But if the value we assumed is not correct, which in this case it isn't, the value of min is 3 right now, then it's going to switch the 0th element, so the I value, and the minimum value which we found. So it's going to switch 1 and 2. So in this switch, which I explained before, it'll become 2 and 1. So now you can see that the smallest element has come in the first index, and the element which was in the first index has come in its place. So it just swapped these elements. Now it's going to come back to the I iteration again. So I will become 1 from 0 to 1, it'll become 1, and min will become 1, which is I. Then j is going to be 2. So now you can see why this is I plus 1, because whenever I is, we want to compare this element, ith element, and the jth element should be 1 more than the ith element. And now you can understand why this is I minus 1. Because when this reaches this element, there will be no I plus 1 because that's not the length of the array. So this condition will become false. So that's why it's a dot length minus 1, because when it reaches this index, the next iteration will be over here. This value will become false and it'll just come out, because then the array will be sorted. Because whenever all these elements are sorted, it's understood that this element is sorted as well, because we can't compare this element to another element after this, because there is no element after this. That's why it's minus 1 and this is plus 1. So then coming back to 7, we have j is equal to 1 in this 2 in this case, and min is 1. So again, it's going to start the tedious process of checking if a of 2 is less than a of 1. So a of 2, which is 4, is less than a of 1, which is true. So it's gonna put the value of min is equal to j. So the current value of j is 2. So min has become 2 now. Then j will become 3 because it iterates. Then it's going to compare the second index to the third index. So the second index and third index is going to compare 4 and 2. 2 is smaller, so the value of min will become 3. And then this is going to go on till the end, and there's no smaller element. So the value of min will be 3. And since our prediction was wrong, it was not I. So then it's going to switch the third element and the second first element. So it's going to switch the third and the first element, because that's the basic code. So min and I get switched, which is basically this first and the third element. So in the same way, this loop will keep on running till a dot length is till I is less than a dot length minus 1, and then all the elements will be sorted. So let me execute this real quick. So I have this selection sort over here, and at the end I've also printed all the elements using the simple for loop. So if I do void main, it prints all the elements in ascending order. Now, if I want to do this in descending order, all I need to do is change this less than sign to greater than sign. And now the condition is going to be the other way around. So if it's greater than, then it's going to switch. So you can see how it's 9874221. So it's decreasing order. Now, this is basic selection sort. Now, I would recommend you don't mug up this code. Don't just learn this code. Understand the concept on how it's done, what the selection sort concept is all about, and write the code yourself. So this way you will not have to learn the code, not mug up the code, and you'll learn the code yourself. So you will make it up whenever you want to use it. Now let's say this is for basic integer. Now let's say let's say I have a string array and there are lots of names. Let's say the name of 30 students in a class. How will I use sorting to put those names in alphabetical order? So if you want to put them in the order of the length, you can just use dot length function over here. So whenever you're comparing, you can just put dot length with that particular string if you want to put them in increasing order of the length. But if you want to put them in alphabetical order, you can use the dot compare to function. So if it's equal to 1, then if it's equal to 0, then both of those names are equal. And if it's greater than 1, then the first one is greater, the first name is greater. So you can use compare to. Basically, if you don't know what compare to is, you can check out my video. I've already made a video about compare to. So if you want to put it in alphabetical order, you can use the compare to function. For character, if you want to compare two characters, sort a character array, you can just convert them into the Unicode equivalent. So 65, 66, 67, 97, 98 into the ASCII values using implicit and explicit type conversion. And that way you can sort a character array as well. So that's it for selection sort. And again, I would like to reiterate my point that I would recommend you practice this on your own and write a code of your own. Now we will move on to bubble sort. Personally, I prefer the bubble sort more than the selection sort. It generally depends on you. You can make your own sorting technique yourself. I like the bubble sort because it's a bit smaller and a bit easier to understand. So unlike the selection sort in which we are selecting the smallest element, in bubble sort, In each iteration, we compare two adjacent elements. So let's say we have an array. Let me take out this pen over here. We have an array. So there are a few elements in this: one, two, three, four, 5 elements. So 0, 1, 2, 3, 4. So what bubble sort does, it compares two adjacent elements. So it'll compare these two, then these two, then these two, then these two. So let's say we are arranging the array in ascending order, small to big. So it's going to compare these two elements and put the smaller one in this place. So let's say it puts the small, let's say it compares the two values. Let's say it's 3 and 4. So this is already smaller. It's going to come here. Then it's going to compare these two. So then again, it'll keep on switching. Then again, it'll compare these two, it'll switch, then these two, and it'll switch. Now you'll understand this later when I show an example, but it's basically just the comparison of adjacent elements. Now let's have a look at an example. We have an array 5, 1, 4, 2, 8. So we have this array 5, 1, 4, 2, 8. And so this is our starting array. Now we'll sort this. So what this x value basically represents, it's the iteration. There is the first pass, second pass, third pass. So it's basically the ith value. So in bubble sort as well, there are only two for loops, nested for loops. So this basically represents the I value. First we have this, and all of these which are happening is in the j loop. So it's in the smaller loop. So this is the bigger I loop. So it'll be the total length of the array. So in this case, it's 1, 2, 3, 4, 5. So it should be less than 5. So it'll iterate 5 times basically. And this is the jth thing. So it's gonna go execute 4 times because again, it should be less than length. So this is what it's all about. And it's not 5 times because again, we can't compare the last element with another element because there isn't. So it's going to only compare 1, 2, 1, 2, 3, and 4 times. So 1, 2, 3, and 4. So it's going to compare 5 and 1, 1 and 4, 4 and 2, 2 and 8, and can't compare 2 with anything. So it's only 4 times iteration. So this internal part is the j, and this x represents the I for loop. Now in the first iteration, we have this thing 5, 1, 4, 2, 8. It's going to compare 5 and 1, and since it's in ascending order, so since 5 is greater than 1, it's going to swap these two, and the new array is going to become 1, 5, 4, 2, 8. Then the 1, 5, 4, 2, 8 is going to compare the next two elements 5 and 4, and since 4 is smaller, it's going to change. So 1, 4, 5, 2, 8. Then it's going to compare 5 and 2, and since 2 is smaller, it's going to swap. So 1, 4, 2, 5, 8 it becomes. Then it's going to compare the final two elements, which is 5 and 8. And since 5 is already smaller, it won't do anything. It'll be no swap. So after the first iteration, you can see that the first element, which is 1, so the smallest element comes in the first index. So you might think of it that way, but that's not how it is. What's basically happening is the largest element is coming in the last position. So here comes the difference between bubble and selection sort. In selection sort, after each particular I iteration, the smallest element in ascending order was coming in the first 0th index. But in bubble sort, after the first pass, after the first I iteration in ascending order, the largest element goes in the final index. So bubble sort works the opposite way around. It sorts from the back. So the largest element comes, then the second largest, third largest, fourth largest, and the last element is the smallest element. So bubble sort is the other way around. Insertion sorts from smallest to biggest in ascending order, but bubble sorts from largest to biggest from the back in ascending order. Now I gets iterated in the next iteration, and then we have the same array over here. This what we left 1, 4, 2, 5, 8. Then it's going to compare 1 and 4, which is smaller. 1 is already smaller, no swap. Then it's going to compare 4 and 2. 2 is smaller, so 2 is going to come over here. It's going to swap. Then it's going to compare 4 and 5. Again, 4 is already smaller, so no swap. And then 5 and 8, no swap because 5 is smaller. Now you can see that the largest after the second iteration or the second pass, the two largest elements are already sorted. They are in their final position. Now what's left to be sorted are these three elements. Now, luckily they are already sorted, but 1, 2, 4, they're already in ascending order. But if they weren't, then they would be sorted in the future iterations. So in the same way, In the third iteration, it'll continue to iterate. Again, it's going to check 1 and 2, since 1 is already smaller than nothing, then 2 and 4, it's already smaller than nothing, 4 and 5, already smaller than nothing, and 5 and 8, already smaller than nothing. So after each I iteration, the final element gets sorted. So in this case, so one largest element gets sorted. After this iteration, two largest element gets sorted. After three largest, then four, and so on. So to save memory and time, what we can do is we can have a -1 statement, so that after each I iteration, we can just have a -1. So let's have a look at the program so you understand what I'm talking about. So I'll open my BlueJ and I have this bubble sort ready over here. Now we have this integer a array, and we have a temporary variable. We don't need a minimum variable like how in selection sort, because it's not about that. So we have int I is equal to 0, I should be less than a dot length, and I plus plus. This is the first basic statement. Nothing fancy over here, no -1 +1. J, we have in j is equal to 0, j should be less than a dot length, but over here we have -1 minus I. Now this is what I was talking about in the PPT as well. Since the final element gets sorted, so after the first iteration, the final element will get sorted. So it'll be -1 minus I. I'll be 0, so -1 minus 0. But in the second iteration, I will become 1. So it'll be -1 minus 1, -1 minus I, which is -1 minus 1, which is -2. So the final two elements iteration will be saved. So that particular time will be saved. Although it's very minuscule, in large arrays, it matters a lot. So then when it goes in the J loop, it's going to start comparing the two adjacent elements. So J and then J plus 1. So if this ascending order, so if the lesser side element is 1 on the left, so the smaller index element, if that's greater, then it's going to swap. Otherwise, it won't. It's the same swapping technique. And then it's going to iterate J will become 1. So 1 is greater than the second one, the first element, and the second one is going to compare. And the pass keeps on going on, keeps on going on. Again, you can see how this is a bit smaller than the selection sort. That's why I prefer this more, and it's easy to understand. And it's a bit more practical, what I feel, but you can use anyone you like. Now, to again, same as selection sort, write this code on your own. Don't just copy blindly. Understand and learn. Now, I'll be showing you a demo, or not a demo, a graphical representation of how a bubble sort works. So I found this on Wikipedia, and there's this awesome animation to explain how bubble sort actually works. So we have this array, and it's going to check the first two elements, 6 and 5, and then it sorts because 5 is less than 6. Then it goes to 6 and 3. 3 is smaller than 6, so it's going to swap. And this, again, this ascending order. Then it's going to compare 6 and 1. 1 is smaller, it's going to go. So you can see how the larger element is just going back and back and back slowly. Now 6 and 8, 8 is already bigger, so it's going to stay there. Then 8 is bigger, it's going to swap in this case. And I would say learn this animation. This is a good animation, and this will help you basically understand the thing. I'll also put the link to this Wikipedia animation in the description, and with this you'll better understand what's happening. So you can see how with this one entire I pass, 8, the element 8 is already sorted. Now it's gonna start the next iteration with I is equal to 1, and since this is already sorted, the final element, it won't compare that. So you can see how 1 and 5, 1 is smaller, so it's gonna swap. 6 and 5, 6 is greater, it's gonna remain. 6 and 7, again, 7 is greater, it's gonna remain. Then again, it's gonna swap because 2 is smaller, and then same for the 4, so it's going to swap. And now you can see how again two elements are now sorted, and it won't go to the 8th element because it's already sorted and there's nothing to do. So now as soon as the pass keeps on increasing, the time taken decreases because the length of the array totally becomes lesser to compare because the end part is already sorted. 6 and 2, 6 is greater, it's going to go again, swap. Then 4 and 6, it's going to swap. And so now the last three elements are sorted. And just like selection sort, if you want to use this in letters, names in alphabetical order, you can do the same compare to, or if you want to do it on the length of their names. If you want to do it character, you can use the ASCII values and so on. 4 and 5 will get switched, and after the 1, 2, 3, fourth iteration, the fourth pass, four elements are now sorted. So the array is halfway sorted, and now it's just left. A little part is left. 3 is greater, it's going to swap, and 4 it's already there. So you can see how the array is already sorted now. Again, this is a lucky case like how I showed. So, but it's still, the program's going to still check. And you can see how much time we are saving when it's not comparing the final parts of the thing. So that's it for the animation. The link again will be in the description if you want to check it out again. And now one final example which I have for the day. Let me just take out my pen. Again, this is the same thing which was in the similar thing. It's a different example, but it's the similar thing. It checks two elements and then changes. So this is only one pass of the bubble sort, and after each pass, which is after every I iteration, the largest number goes at the end. So 90 is at the end, so which is the largest number. And just a quick note, if it was descending order, then the smallest element would be sorted to the end. So if it was descending order basically, so the smallest element in this case is 5. So my bad, what just happened? I think, yeah. So the final element, which is 5, will go in the last position because it's decreasing order. So that's how it is. And if I want to make this decreasing order, I can just do less than sign. And now this has converted to decreasing order. So if I do void main, it should print from largest to smallest. And again, if it's ascending order, just the other way around, like how it was before, and it's ascending order now. So these are the two codes for bubble sort and selection sort. This for selection sort, and this is the code for bubble sort. The ending part is just for printing. It's not technically part of the code. It was just to test the output. So again, you can use any method of sorting. There are other methods as well, like insertion sort. So I personally prefer bubble sort. You can even make a sort of your own. Like personally, I have my own sort, which is like a mixture of both bubble and insertion sort. It's kind of weird, but I would say you focus on bubble and selection sort only. So here are the two codes. Write this on your own, practice, and implement them in your array codes. So that's it for today, everyone. Thanks for watching. And if you have any queries, doubts, or suggestions, you can mail me. My email will be in the description down below. And thanks again for watching.